It's our another question, which is it is equal to melt 5 tons per hour of iron from a charge at 15 degrees Celsius to molten melt at 1650 degrees Celsius. The melting point is 1535 degrees Celsius and the latent heat is 270 kilojoule per kilogram. The specific heat is solid state is 0.502 and it is liquid state 29.93 per atomic weight and kg kilojoule per kilogram Kelvin. If an electric furnace has 70% efficiency, find the kilowatt rating needed. If the density is molten state is 6900 kilogram per meter cube and the watt volume is 3 times the Hertzle melted rate. So and then find the dimension of the cylinder furnace if the length of diameter ratio is 2. The atomic weight of iron is 56. So there are two questions. Number first, find kilowatt rating needed and find the dimensions of the cylinder furnace. So solution is here required to melt 1 kg of iron at 15 degrees Celsius to molten at 1650 degrees Celsius. So the here required to melt 1 kg of iron at 15 degrees Celsius to molten metal at 1650 degrees Celsius. It is equal to heat required to rise the temperature from 15 degrees Celsius to 1535 degrees Celsius to rise the temperature from 15 degrees Celsius to 1535 degrees Celsius plus latent heat plus heat required to rise the temperature from 1535 degrees Celsius to 1650 degrees Celsius equal to raise the temperature from 1535 degrees Celsius to 1650 degrees Celsius. So now we put the value. So it is 0.5602 into 535 minus 15. Rise the temperature is from 15 degrees Celsius to 1535 degrees Celsius. So we minus from 15 from it, and it is the from we take it from specific heat from here, and plus latent heat is 270 from here. It is latent heat and plus 29.93 into 1650 minus 1535. So it is we subtract 1535 from 1650, and it is from here. So from here we get 763 plus 270 plus 61.5. So it is equal to 1094.5 kilojoule per kilogram. So now 1 ton is equal to 10 to the power 3 kg. So melting rate is equal to 5 into 10 to the power 3 kilogram per hour, and therefore the rate of heat supply required the rate of heat supply required is 5 into 10 to the power 3 into 1094.5. we get it from there. So it is in kilojoule per hour. Now since the furnace has 70% efficiency, the rate of the furnace would be now the rate of furnace would be rate of heat supply per second, rate of heat supply per second by furnace efficiency, EFFICIENCY efficiency. Okay, so from here it is 5 into 10 to the power 3 into 1094.5. it is in hours. Now we convert it from hours to second, so we divide it by into 0.7, so we get it 270 into 10 to the power 3 kilowatt. It is our first answer. Now volume needed is equal to 3 into 10 to the power 3 into 5 into 10 to the power 3 divided by 6900 meter cube, it is equal to 2.18 meter cube. So now if d is the diameter and l is the length of the furnace, if d is diameter and l is the length of furnace, so pi by 4 d square into l is equal to 2.18 meter cube, and pi by 4 d square into 2d. 2d because in question we have the dimension of the, if the length is length to the diameter ratio is 2, it is given in the question, so we put l is equal to 2d, and it is now it is equal to 2.18 meter cube. So now from here d is equal to 1.15 meter, so it is d, and from question that l is equal to 2d, so l is equal to 2 into d, so l is equal to 2.30 meter. It is the second answer. So thanks, and please subscribe my channel.